Hello, let's continue our Sudoku adventure with T for 2 by ZegreS. So this continues our Parody Diamond theme week. Hope you're enjoying it. Let's go over the rules to this one. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have black diamonds in the grid. Digits separated by a black diamond have the same parity. Parity just being the property of being even or odd. So these are either both even or both odd. There are also circles in the grid attached by arrows. We call this arrows in general. Digits on an arrow sum to the value in the circle. So if this was 2 plus 2, or if these were both 2, we would do 2 plus 2, we'd put 4 in the circle. If it was 2 and 3, we'd put 5 in the circle. There's no additional non-repeat rule introduced by arrows. We just have normal Sudoku rules for non-repeat. We like to specify that whenever there's a sum-related constraint because people are used to killer cages, and killer cages happen to come with a non-repeat constraint usually. Most other sums do not though, but we like to specify that anyway. All right, so those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Well, my eye is obviously drawn here, because these are the same parity, these are the same, these are the same. So all four of these are the same parity as each other. So they're either all even or all odd. Okay, so that means that both of these add to an even number. I'm going to use blue for even. Now the reason I know that is because these two are the same parity as each other, and two digits of the same parity always sum to an even number. So that means all four of these together sum to an even number. Let's think about what's possible here. So the minimum this could add to is 6, and the max it can add to is 10, because 4 plus 6 is 10. And since they're both even, we can't do 5 plus 6. So 10 would be the max, 6 would be the min of the sum. And it's all same parity. So what's the minimum this could add to? Well, we could do 2, 1, 3 pairs. So that would add to 4 plus 4. That would be 8. That would be pretty middling. That would be fine. Let's see. What if the minimum would be if these were even would be 2 4 pairs. That would add to 12. That's too big. So I think we just proved that these have to be odd. That's cool. Because if they were all even, the minimum I could do is 2 2 4 pairs, and that would add to 12 in total. So these two would have to add to 12 in total, and we can't do that. They'd have to both be 6. So yes, these are odd. Now, can we include a 5 at all? I guess is the question. If I include a 5, then I could do 2 1s and a 3. I think that's too much. Is that too much? 5, 6, 7 plus 3. No, that's not too much. So I could include a single 5 in here, can't I? Well, okay, but then what? Oh, I see. But then this would add to 8, right? And that's the only way I did that is in order to repeat the 1, I put them next to the 5. If I wanted to do 5 plus 1 to actually stay within the range of 6, now suddenly these are both 3, and now both of these add to 6. We'd have a total of 12. So actually, I think we just proved that these are 1 3 pairs. So that's neat. Which means that. Right, and we can't do. Wait, they can't be 1 3 pairs this way because of Sudoku, but also because then these would both be 4. But I think Sudoku might be an easier argument. These are the same digit as each other, so we have one that's 1 plus 1 and one that's 3 plus 3. So this is actually a 2 6 pair adding to 8. Yeah, because we know this total is 8. And actually, that's the only way to get to 8 is 2 plus 6 with even numbers. Okay, this is all making sense. Where do we go from here is really the question. Well, 1 3 pairs. This adds to a digit that's at least 3 because these can't repeat. And in fact, this cell here, I guess we could put a 1 here. We could do 1 2. That would work fine, and that could add to 3. But this can't add to 3 because of the 1 3 pair. So this is 4 5 6 is what I'm trying to say. I don't know the parity though. Does it have to do with these black diamonds maybe, or let's see, this is. Are we worried about where to put 6? Not really. I'm trying to think what's the next restriction here. Because these 1 3 pairs remove 1 and 3 from the rows. Right? So I mean I guess I could fill 2, 4, 5, 6 if I wanted to. We don't actually have 2 odds left. Right. I'm feeling this actually helped. These have to be both even because we don't have 2 odds left. They'd both be 5 if these were odd. So these are both even. Very nice. So these aren't 5s. We're not putting 6 on an arrow. So those aren't 6s. We get a 2 4 pair. So we end up with a 5 6 pair here. Okay, so if this is even, what's that mean for this sum? I'm not sure what it means for this sum, to be honest. This sum is at least 4. This is 4, 5, 6, because this is minimum 2, this is minimum 2. Just a very naive calculation there, but I think it works. I'm thinking about if this was 2, then that forces this to be 2, which forces this to be 4. And then this would be 5 or 6, but I don't think it could actually be. Could it be 6? No. Maybe. No, it couldn't, because this would be 6. So if this was 2, this would be 5, this would be 4, and this would be 1. That would resolve a bunch of stuff, but I think it actually works. So what am I actually supposed to be doing here? Well, this is not going to be a 6, because that would be too big. In fact, 5 is too big as well. So this is even. This is a 2, 4. Okay. So that's all our evens. This has to be odd, so it is a 5. That's a 6. So it's even. 5 is odd. This is 2 and 6. Didn't resolve the way I was thinking earlier, but that's okay. Oh, this is a 4, so it has to be 2 plus 2. That's 4. That's 6 and 4. This has to be 1. Okay, and that resolves our double 3 and double 1 in the correct order. I could have resolved that as soon as I placed these, I guess. It's okay. All right, so these are odd. And we know what they are. This is 5. This is 1. These are both odd, and these are both odd, because 2 evens are already used up. All right, so that's even. Do I know what's going on here? Yes, I need this. I need a 4 in this box, and this 4 says not here. So that's a 4, which is even. That's odd, which is a 3. So this is DT2 in the corner. We need a 1 in this column. This can't be the 1. So this is 1. This is 5. Now this sees 5 and 1, so this is a 3. And this sees 1 and 3, so it's 5. These are all even for the row. So these are a 2, 6 pair, and we know the order because of the boxes, 6 and 2. All right, I think we're just finishing now. This is a blue 2, and this is a 6. All right, so I need a 6 in the box that goes here. I need a 2, which goes here. Oops, not gray. All right, these are both, oh, sorry, one of these is 3, and one of these is 4. Okay, so the 4 goes here. This is an orange 3. And then this is our 3, which is orange. This is also orange, which is 5. Yeah, we can finish these columns. This is blue. This is orange. We get a 1 and a 4, and we're done. Cool puzzle, ZegreS. Yeah, had to think. I think thinking about the total sum combined here was really key, because it forced them to be odd, and it also forced them to be 1, 3 pairs. I thought at first we could get away with a single 5, but it forced the 1s to go in the wrong place, because 5 had to go with a 1. As soon as you did 5, 1, then it became obvious that this would have to be 3, 3, and these would both, that would be adding to 12, which is too big, because our maximum sum was 10. So with the maximum sum of 10, 1, 3 pairs was the only option, which is really interesting. So cool break in there. And then, yeah, it took a little bit of thought on how these arrows and these diamonds interacted. But yeah, that was neat. I enjoyed that. Hope you enjoyed it as well. If you did, then why don't leave a like, subscribe, and a kind comment below.